Hello, hi everyone. Welcome to the Student the Brand. This is your Siva sir. So today topic is electric current, CBSE Grade 10 Physics. So now electric current. Electric current is nothing but rate of flow of charge. I equal to Q by T. I equal to Q by T. SI unit of current is ampere. SI unit of charge is coulomb. SI unit of time is second. So 1 ampere is defined. So SI unit of current is ampere. SI unit of charge is coulomb. SI unit of time is second. 1 ampere is defined as 1 coulomb of charge flowing through unit cross section area per second. 1 ampere is defined as 1 coulomb of charge flowing through unit cross section area per second. Okay, so that is about SI unit of electric current. So current is nothing but the flow of charge. The flow of charge per unit cross section. The flow of charge through unit cross section area per second. Net charge flowing through unit cross section area per second also we can say. Okay, simply we can say the rate of flow of charge. Simply we can say the rate of flow of charge. I equal to Q by T. I equal to Q by T. 1 ampere is defined as 1 coulomb of charge flowing through unit cross section area per second. 1 ampere is defined as 1 coulomb of charge flowing through unit cross section area per second is called 1 ampere. 1 ampere is nothing but 1 coulomb of charge flowing through unit cross section area per second. So I am taking this the conductor. This the conductor I am taking. Okay. So positive charge, negative charge, positive charge, negative charge, positive charge, negative charge, positive charge, positive charge, negative charge, like this I am taking. Like this I am considering here. Okay. So if only one electron flows, will you say current is flowing? Only two electrons flows, will you say current is flowing? So we can't say. There are many charges are moving inside of the conductor, then only we can able to say current is flowing in the conductor. So Q is nothing but Ne, plus or minus Ne we are taking. Plus is nothing but positive charge, minus is nothing but negative charge. Positive charge is proton, negative charge is electron. Q equal to Ne. Okay, sir. Excellent. Marvelous. I understood what you said. So, what is the value of electron? On one electron, how much charge is present? On one electron, how much charge is present, sir? You tell me. On one electron, 1.6 into 10 power minus 19 coulomb. Sir, I have one more doubt, sir. In one coulomb, how many electrons are present? In 1 coulomb, how many electrons are present? In 1 coulomb, how many electrons are present? So that is one more question. So in 1 coulomb, 1 by 1.6 into 10 power minus 19. Then 1 coulomb, 1 by 1.6 into 10 power 19. Then you will get here, say 1 coulomb, 1 by 1.6 into 10 power 19. Then 1 coulomb, 10 by 10. So if you are taking 10 by 10, we can consider here. Okay. So 1 by 10 by 10 into 10 power 19. Then you will get 1 coulomb 10 by 16 into 10 power 19. Okay, so then 1 coulomb equal to, if you do this 0.625 into 10 power 19, then 1 coulomb 6.25 into 10 power 18 electrons are present. So in 1 coulomb 6.25 into 10 power 18 electrons are present. I hope it is very clear, right? So is it clear? Is it clear? Yes or no? Yes. Now, so I equal to Q by T, 1 ampere equal to 1 coulomb per 1 second. So charges are moving. Q equal to Ne, and 1 electron 1.6 into 10 power minus 19 coulomb. 1 coulomb 1.1 by 1.6 into 10 power minus 19. So if you do this, you will get it In 1 coulomb, 6.25 into 10 power 18 electrons are present. Okay, done. So now, so torque is nothing but force into perpendicular distance. So best example, opening the door, closing the door, opening the bottle cap. Okay, force into perpendicular distance. Or opening the door and closing the door is a best example. Okay. Now, and that's enough. Now, so we'll discuss about one more. So now we will discuss about electrical appliances. Now we will discuss about electrical appliances. Tensile strength. It depends on strength of the material when we are applying force. Okay. Come to the point now. So cell, this is the cell, positive terminal, negative terminal cell. Second one is battery, positive terminal, negative terminal battery. So next one, third one is switch. So this is the open switch, and next one is fourth one is closed switch, and next one ammeter I'm taking. So this is ammeter. Next one voltmeter. Seventh one resistor. This is the resistor. Coming to rheostat. Either you can take like this or you can take like this also. Rheostat. Okay. Now you can observe here. So cell, battery, open switch, closed switch, ammeter, voltmeter, resistor. Here is the resistor. So resistor I am taking here. This is the resistor. And this one is the rheostat. The next one, ninth one is. So here I'm taking wire joining. 10th one is wire crossing. 11th one is wire joining, wire crossing, ammeter, voltmeter, bulb. So we have to take the bulb. So this is the bulb. Okay. So I hope it is very clear. Hi everyone. Welcome to the class. There was so many cool. So I am fine. I am doing good. Great. Okay. So here you can observe. So cell, battery, open switch, closed switch, ammeter, voltmeter, resistor, rheostat. And next one's everything we discussed. Now I will explain about circuit. So electrical circuit. So what is an electric circuit? What is an electric circuit? Circuit. Electric circuit. Mhm. 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 Okay, done. Chalo. Next, we'll discuss about one more. That is about an electric circuit. So here I am taking the cell. Battery I am taking. Current is flowing. This is a resistor. Resistor. So switch we can take. Switch. I am taking the switch here. Closed switch. Current is flowing. Okay. So a continuous and closed path, or instead of resistor, so I'll be taking a bulb. So instead of resistor, I'll take bulb. So I hope it is very clear to you all. I am taking the bulb. Okay. So this is a bulb. So here, so bulb is glowing. So positive terminal, negative terminal current is flowing. So here, what is an electric circuit? A continuous and closed path of an electric current. A continuous and closed path of an electric current is known as an electric circuit. A continuous and closed path of an electric current. A continuous and closed path of an electric current is known as an electric circuit. An electric circuit. Okay. Now, first point is conventional current. Conventional conventional current. Conventional current, and the second one is electric current. Conventional current and electric current. Conventional current is nothing but, so the flow of positive charges is known as conventional current. The flow of positive charges is known as conventional current. Flow of positive charges. Positive charges will move from high potential to low potential, whereas electrons will move from low potential to high potential. Is it clear? Conventional current. So now we are discussing about conventional current. Conventional current is nothing but, so previously before finding electron, proton, everything, so they already given the statement, the flow of positive charges so is taken as current, but after knowing electron, proton, everything, so the flow of electron gives the electric current. So already it was given, so that's why we are considering the same, we are using the same. That's why it is called conventional current. The flow of positive charges is known as conventional current. The flow of electrons is known as electric current. The flow of positive charges. Positive charges will move from high potential to low potential. So this is the high potential. Positive charges will move from high potential to low potential, whereas electrons will move from low potential to high potential. Positive charges will move from high potential to low potential, whereas electrons will move from low potential to high potential. Conventional current. Conventional current is nothing but flow of positive charges. Flow of positive charges. Positive charges will move from high potential to low potential, whereas electrons will move from low potential to high potential. low potential to high potential. I hope it is very clear to you all. So conventional current and electric current. Now we will discuss about one more, that is conventional current and electric current. Next one, electrical potential and potential difference will discuss. Electrical potential and potential difference. Electrical potential so now potential difference will discuss, then electrical potential. Potential difference. Potential difference. Potential difference is nothing but work done to bring unit positive charge. Work done to bring unit positive charge from one point to another point within the conductor. Work done to bring, so I am taking here, so this is a point A and point B. We are doing some work. We are doing some work to bring unit positive charge from one point to another point within the conductor is called potential difference. 1 volt equal to 1 joule by 1 coulomb. 1 volt equal to 1 joule by 1 coulomb. Okay. Now we can go for electrical potential. Electrical potential is nothing but electrical potential. So this is potential difference. Now electrical potential. Electrical potential. Electrical potential is nothing but work done to bring unit positive charge from infinity to the required field. So I am taking this one. So this is the infinity. So we are taking the positive charge. We are doing some work. So we are bringing the positive charge from infinity to the required field. We are doing some work. We are doing some work to bring unit positive charge from infinity to the required field. From infinity to the required field is called electrical potential. So V equal to W by Q. Potential difference is nothing but work done to bring unit positive charge from one point to another point within the conductor is called potential difference. V equal to W by Q. 1 volt equal to 1 joule by 1 coulomb. Electrical potential is nothing but, so V equal to W by Q. We are doing some work to bring unit positive charge from infinity to the required field. From infinity to the required field is called electrical potential. Okay, done. Now we will discuss about one more, that is about so Ohm's law will discuss now. Ohm's law. Ohm's law. Ohm's law. So Ohm's law is nothing but the potential difference. So I'm taking this is a resistor. This is the resistor. So VI connected. So that is voltmeter. And ammeter I'm taking this ammeter. So we are considering the four cells. Switch. Okay, so current is flowing, positive terminal, negative terminal, current is flowing, right? Yes. Now we combine here, so I'm taking like this, current is start flowing because, so these dotted lines represent, we are connecting one by one, so one by one we are connecting like this. Okay, so now you can observe the potential difference across the resistor is directly proportional to current flowing through it. The potential difference across the ends of the given metallic conductor is directly proportional to current flowing. So V is directly proportional to I, V equal to IR. V equal to IR. V equal to IR I am taking. V equal to IR. Okay. So I equal to V by R or R equal to V by I. Ohm's law gives the definition R equal to V by I. Sorry. R equal to V by R equal to V by Ohm's law gives the definition of resistance. Ohm's law gives the definition of resistance. Now materials required. What are the materials required? Materials required. First one, 4 cells. First one is 4 cells. 4 cells, 1.5 volts of each. 1.5 volts of each. Second one, nichrome wire. Nichrome wire is an alloy of nickel, chromium, manganese and iron metals. Nichrome wire is an alloy of nickel, chromium, manganese and iron metals. Okay. Next one, voltmeter V, and coming to ammeter, fourth one is ammeter A I am taking, and fifth one switch I am considering, and sixth one is connecting wires. So now you can observe. So what are the materials required? First one is, so 1.5 volts of each, nichrome wire, voltmeter, ammeter, switch, connecting wires. So what is the procedure? To do the activity, experiment. First one, procedure is first you have to connect one cell and note down the reading of ammeter and voltmeter. Here you can observe 1, 2, 3, 4. 4 cells are there. 1.5 volts each. 1.5 volts each. 1.5 volts each. Okay, so next connect to 2 cells. 2 cells and note down the reading of ammeter and voltmeter and connect 3. Repeat the process for 3 and 4. Repeat the process 3 and 4. 3 and 4. Repeat the process. Repeat the process by connecting 3 and 4 cells and mention the note down the values of ammeter reading and voltmeter reading and mention in the tabular form given below. So I am drawing, this is the tabular form, so you can mention in the tabular form. Okay, now serial number of cells, ammeter reading, voltmeter reading, V by I form. Okay, so once again, serial number, number of cells, ammeter reading, voltmeter reading, V by I, that is nothing but R value. V by I is nothing but R value. I hope it is very clear to you all. Okay. Now, so how many cells we are taking? 1, 2, 3, 4. 1, 2, 3, 4. 4 cells I am connecting. So if you draw the graph for Vi, so now Vi graph gives the straight line. So I am taking V on y-axis, I on x-axis. The graph is straight line. It is for ohmic conductors. And coming to the next one, so the graph is curved for non-ohmic conductors. So I am taking like this. So V on y-axis, I on x-axis. Okay, so this is for non-ohmic conductors. Non-ohmic. Sir, what do you mean by ohmic conductors? And what do you mean by non-ohmic conductors? Ohmic conductors are nothing but the substances which obey Ohm's law. Those are called ohmic conductors. The substances which does not obey Ohm's law, those are called non-ohmic conductors. Ohmic conductors and non-ohmic conductors. I hope it is very clear. So this is about clear idea of Ohm's law. First you have to take 4 cells and nichrome wire, ammeter, voltmeter, and voltmeter. So next, so you can check once. Okay, I hope it is very clear. So this is about Ohm's law. Done. Next we will discuss about resistance and resistivity. We'll discuss. Actually, Ohm's law gives the definition of resistance. Okay, resistance and resistivity. So R is directly proportional to length of the conductor. R is inversely proportional to area of the cross section. R directly proportional to L by A. R equal to rho into L by A. Okay. So SI unit of resistance is ohm. SI unit of resistance is ohm. SI unit of resistivity is ohm meter. Okay. So rho equal to RA by L. Okay. So rho equal to RA by L. Ohm meter square by meter. Meter get cancelled. Ohm meter. So this is SI unit of resistivity. Okay. So until here we discussed. So we'll continue the next part. So if you like the video, do like, share and subscribe to Student the Brand. So if you like the content, if you like my explanation, you can do like, share and subscribe to Student the Brand. Okay. So you can share to your friends. Ask your friends to join to the class. Thank you so much for joining and attending and listening. Thank you.